Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hi, in the given problem, there are two rods which are rotating about their fixed end in a plane. So, the paths followed by both of the rods is like this. So, these are the rods which are having a 1 millimeter gap between their ends when these ends reach to the closest position between them. So this gap is given as 1.0 millimeter. The magnetic field perpendicular to the plane of paper in which these rods are moving is given as B is equal to 4.7 Tesla. Length of each rod is given as 0.68 meter. Then the potential required to create a spark within this gap is V is equal to 4.5 into 10 raised to the power 3 volt. So the EMF, the motional EMF generated across each rod should be equal to half of the value of this net potential difference required between the ends of these two rods. Means it should be equal to 4.5 by 2 into 10 raised to the power 3 volt, means this is 2.25 into 10 raised to the power 3 volt. So using the expression for motional EMF across a rod when it rotates in a magnetic field, that is given as EMF epsilon is equal to the product of B into the average velocity of the rod, V average, multiplied by the length of this rod. So we can say this average velocity as the velocity of the end about which the rod is rotating is 0. Here this V is 0. Here we can consider this velocity as V. So we can say the average velocity comes out to be 0 plus V by 2 into length. Hence, finally, we can say this is half into BVL. So finally, for this linear velocity, we can use the expression, the relation between linear and angular velocity says V is equal to R omega. For R here, this is the length of the rod, L omega. So finally, expression for EMF induced is half into B into L omega into L. So this expression for EMF induced comes out to be half BL square omega. So finally, in order to find the angular speed omega, the expression for this omega becomes omega is equal to 2 times of EMF induced divided by B into L square. So plugging in all known values here, this is 2 times of 2.25 into 10 raised to the power 3 divided by magnetic field, which is having a value of 4.7 Tesla, multiplied by the square of the length of the rod, which is 0.68 meter, having whole square. So finally, this angular speed comes out to be 2070.6 radian per second. And this is the answer for the given problem. Thank you.